Okay, so we are ready for our next speaker. Just before that, I want to let you know that there is a special area on the right corner where you can meet all of the speakers after that and have a chat if there is no enough time for questions. So our next speaker is Aleksandrina Todorova. She's a quality engineering leader at Musala Soft and an IoT expert. In the past couple of years, she's working on smart home platform solutions. And today, she would like to share with us the challenges her team had with the physical dependencies and the devices, especially when the pandemic started. So, Alex, the stage is yours.
Thank you. Thanks for presenting me. And today I want to share with you the challenges we had the past couple of years since the pandemic started. So I'm working in the IoT industry for more than 5 years. And I'm passionate about automation, testing strategies, and infrastructure configurations for efficient CI/CD. And as I mentioned, we will talk about Internet of Things. This is the agenda, and we will speak of what IoT actually is, and more specific, our smart home solution. As well, I want to share with you what actually do I mean by physical dependency and how we have managed to solve it using mock services. So, Internet of Things. I think that most of you already know what the Internet of Things is and are somehow part of it. But the thing is that it is a network of physical devices connected to the Internet worldwide. So those devices are all collecting and sharing data. And today, worldwide, there are like 10 billion connected IoT devices, and experts are expecting this number to grow up to 22 billion by 2025. So today, there are more smart devices worldwide than human beings. And to get a better understanding, I will start with an example from my current project. Imagine a cloud-based smart home platform which allows the customers to connect devices from different manufacturers and to create automations and configurations based on their setup. You probably all have some smart devices at home. For example, if you have a vacuum cleaner, this vacuum cleaner has its own application to be controlled. If you have a smart camera, you have a second application for this. If you have a smart air conditioner, you have a third application. And that's what we are not doing here. We want to have one platform for all of the vendors and to be able to create automations between them. So the automations that we can make are like turn on the vacuum cleaner when I leave my house, close the shutters when it starts to rain. And my favorite one is simulate presence when I'm on a vacation. So it happens by sporadically turning on lights, music, and TV on. And in order to test this platform, we have a team structure with distributed teams, where each team is responsible for a specific feature. The development happens on feature branches, and a smoke test set of the automated tests are running against those feature branches. And when the time for a release comes, we are creating a build from the master branch, and we are performing full regression testing. And we have like 800 test scenarios per platform, which are partially automated. And in order to test them, we have physical setups at the office with connected physical devices and gateways. And going back to the example for the shutters and the rain, in order to test it, we need to take the actual sensor and to put it under a running water and to verify that the shutters will actually close. And dependencies. What is the physical dependency? Actually, currently in the IoT world, there is no answer of that question. What is actually the physical dependency? But what we need to know is that we need to make sure that the devices work together. And as I mentioned, there are more than 10 billion devices worldwide. So in order to test, we cannot ensure that our product will work with all of them. And as well, they cost money, they are taking up space, and they need some additional resources like internet, Bluetooth, or other connectivity. They need electrical installations and batteries. So this is how much batteries we are consuming in order to test those devices. And to get a better vision how the real testing environment looks like, I've made some pictures of our office. So these are the devices. We have like thousands of devices, from smaller ones like bulbs, door window sensors, grass mowers, and dishwashers. And here are two pictures from the testing labs that we have for the laundry space and the kitchen corner. So you probably think that we are washing our clothes there. Actually no, but the fridge is full with wine for successful deliveries. And here the challenge came because we have, as you see, we have one fridge, we have one washing machine, and we have 16 distributed teams that sometimes they need to test those devices, so they need to wait on a queue for the resources. That's not a problem when we are at the office, but the problem scaled when the pandemic came. We needed to find a way to keep people safe by moving them at their homes and not to interrupt the delivery process at the same time. And how to move this fridge at home? First of all, we decided to split the smaller devices, like the door sensors, the bulbs, and we have created testing environments at people's places. And for those bigger devices, we have mounted cameras in order to observe their behavior remotely. So the last thing was some network configurations were changed at the office so we can access the devices remotely. And yeah. This is, on the left, this is the grass mower, and on the right, it is the vacuum cleaner. Okay, we found a way to somehow manage to proceed working with this setup, but still, the successful product needs more and more resources, so we needed to find a way to multiply those devices, and we decided to go for mocking the services. We have implemented mock services and virtual devices. So the reason was that we wanted faster and independent automated tests. We wanted to have a wider variety of devices and states so we can provide, actually every team can create a setup based on their needs and to simulate the states of the devices if they are on or off, if they're showing a specific temperature value or volume of a speaker, and scalability. And the technologies for mocking, we conducted research for some of the existing solutions that were on the market about mocking, like WireMock, but they were either too expensive or they did not meet actually our requirements, because the most important for us were to persist the state of the devices. And what do I mean by persisting the state is, imagine that this cloud here is the environment, the mocked environment. We have the environment, we are deploying the mocked services on it. And this is the testing team. They all want to test on this environment. For example, tester 1 wants to simulate the change of the state of mock device, which is, on this example, a white bulb, which is turned on 100% brightness. And in that case, with the existing solutions, it is changing the state for all of the users logged into this environment. And what we've made a custom solution using Quarkus framework. And what we gain from that is that same environment, same deployment mock services. And here in this example, the tester is changing the state of the brightness state of the white bulb, and it is not affecting the work of any of the other users. So in that way, we can test independently and we are not interrupting the work of the other team members. And what are the benefits from mocking? Improved parallel run. So in the beginning, with the real setups, we have 2 real setups with 2 gateways and connected devices to them. And imagine the pipelines. You have like 50 pipelines per day that are running. They are put it on a queue. So the first pipeline is getting the resources, and the other pipelines are in a pending status until the resources are freed. So in that way, using mock services, we can create a separate environment for every feature branch. And that's how we can run multiple pipelines simultaneously. The second one is, as I already mentioned, wide variety of devices. Every team can configure the desired setup. Everyone can have a fridge and oven and so on. And the state simulation, remember the example with the white bulbs? We can simulate all of the desired states that a device has. And last but not least, the environmental impact. We have dramatically reduced the energy consumption, the usage of batteries, and plastic for the device itself. And as well, those are the challenges that we had. The first one was that mocks are not 100% reliable. We have increased costs in the beginning and time-consuming connection creation for the mock services, and we'll go one by one. So the first one is that we cannot rely 100% on something that is not real, because that's not what the customer will receive after all. The customer will receive a physical product with electronic parts, firmware, and so on. And what we did to ensure that our product will work, we have created a nightly schedule with the automated test that is running against real setup. So the pipelines during the day are running with mock services, and everything that goes to the master branch is tested during the night, and in the morning we can see the reports of the real environment results. And the second one is the increased costs. This means that we have, with this implementation of the mock services, we have increased the money that we are paying to Azure for pod usage, and it's scaled up to 1,000 euros per day on top with what we paid. So initially, imagine the temporary environment, the blue ones are the temporary environments. We have this temporary environment, we are deploying the mock services. We are creating a separate environment, we are deploying the mock services again. And those deployments are consuming the resources. So we needed to find a faster way to save some money. And what we did, the purple one, I hope that you can see it well, is a temporary environment. We have created a temporary environment with pre-deployed mock services and a bridge implementation that is using the already deployed services. And that's how we have decreased the expenses to less than 300 euros per day. And the last one, the initial connection of the mock services is time consuming. What I mean is that the real setup is already configured. Someone have configured it with real gateway, real connected devices, and all we need to do is just to log in with a specific user and password, and we are starting to use those devices. But for the mock services, it's not exactly the same case, because we have the environment, we need to wait the deployment of the environment, the backend services, the mock services. After that, we are logging to a brand new environment, and we need to go through all the pairing flows. For example, we want a bulb, we need to go select bulb model, etc. We want to have some additional devices. And we are going to this flow, and it is taking up like 5 minutes, 10 minutes, 15 minutes. It depends on the amount of devices that we want to connect. And together with the development team, we've decided to implement some solution that is adding the devices automatically on the login. So that's how we have speeded up the tests with around 10 to 15 minutes. And as well, we have checked the performance of the automated test itself. We did multiple things to save the time and the connection creation improvements, and we have removed some weights, and some functions were improved and refactored in order to make the tests running faster themselves. And the last thing was that we decided to create a smoke test set and a full regression test set. The smoke test set contains the critical priority test cases, and it is executed, as I mentioned, on the feature branches during the day. It is running on mocked environment, and the full regression test set is the one that contains all the priorities. And it is running against a real environment during the night. And this is one example of how we are handling the conditions in the test. If you want to run a specific test on a mocked environment, on a real environment. The ones in the brackets are the parameters that we are putting the exact conditions in order to differentiate if you want to run those tests on mocked or on a real environment. And if we leave it empty, it means that those tests are supported for both environments and we can proceed without failing tests. And after those metamorphoses, this is the final look of pipeline configuration. So the first step is creating the environment. After that, we are deploying the mock services or the real services, depending on our needs. After that, we are executing the automated tests, and we are creating a report of the quality of the desired branch. And as well, the last stage is to destroy the environment, which is saving us some resources that are not needed anymore. And here is an example, just a short example how the reports look like for the automated tests. On the left, you can see the tests that are running on mocked environment. You can see that they are less than the ones on the right. That's because those are the critical scenarios from a specific feature. And on the right, here, it is the report which is running during the night on the live configuration, and it includes all the priority test cases. And that's how we have managed to decrease the time for pipeline execution from 60 minutes to 20 minutes. And what I want you to remember from my presentation is that think of something that is taking you time, resources, or any kind of effort, and together with your team, try to find a solution for this, because you can always decrease the time that is needed for a specific thing to be done. So, thank you. And if you want, we can chat a little longer after on the, what was the launch? The speakers want, yeah. Do you have any questions now? Wait for the mic.
So my question is about the night run on the live environment. Do you make assertions, for example, the light bulb, if the test tests the brightness from 20 to 100%, do you make assertion if the real device actually become brighter? If the bulb
actually, on this stage, no. We are verifying those states manually on the regression phase. We are verifying that the changed state is activating some automation, for example. When the example with the water sensor, if we have water, we want something else to happen. And we can simulate the water and to see if the result of the other connected device will be the expected one. But we need to ensure that the customer will, this scenario will work with the customer, so we are testing as well on real setup. The ones that are in our homes and the ones that are at the office.
Thank you.
Thank you.
Hello. Should I understand that with the mocking services, your test engineers are having better environment for producing tests and they are more efficient?
Yeah.
Thank you.
Any other questions? If not, we have a question.
Yeah, so thank you very much for the lovely presentation. It seems that you have a lot of fun into the lab. Can I just volunteer my home for the vacuum cleaner test? No, this is not my question actually. What about the security?
With the beginning of the pandemic, one of our colleagues took it at her apartment, and it was running like 10 hours per day, and her neighbors started complaining about the noise, so we put it back in the office with a camera.
Yeah, so a lot of fun during the pandemic. What about the security? Because we know well-known hacks through the vacuum cleaners or another IoT devices, and after that, the hackers were able to penetrate through your Qualcomm network and then steal your private data, for example.
Actually, we are using external APIs. We have integrated the external APIs of the vendors, so we depend on their security implementations.
Yeah, okay, thank you.
Thank you. Okay, thank you.